Now we're going to our another favorite section of the show. I personally love the stuff these people do out here. Our student innovation, and this time it's the Delhi College of Engineering that gets into the act. Now they've made a vehicle, and I could sit here, stand here, and describe the amount of things it can do. But then, of course, I could just show you. So here we go.
VARUN is the name given to this vehicle for automation research and underwater navigation. It has been designed by a team of 10 students from Delhi College of Engineering with the aim of competing in the 11th Annual Autonomous Underwater Vehicle Competition hosted by AUVSI and ONR.
The basic principles that are involved in this vehicle are image processing, then artificial vision and control systems. For image processing, we have cameras installed in this robot. These cameras take underwater images, and then through the onboard processor, these are processed, and whatever the detections are to be done, that are done in that. And finally, the target that has to be done is done by the artificial vision algorithms.
An autonomous underwater vehicle is a submersible, tethered robotic submarine that is capable of performing complex tasks without aid from human operators. It is powered by batteries or fuel cells and travels underwater and can operate in water as deep as 6,000 meters. Advances in propulsion systems and power source technology give these robotic submarines extended endurance in both time and distance.
To begin with, the vehicle, the mechanical model consists of three main parts: the metal frame, the wings and the waterproof hull. As you see, on the metal frame is used for generally the mountings. We have two vertical thrusters, one in the front, one in the back, for the vertical motion, and two horizontal thrusters for the forward and backward motion, as well as the turning. On the main hull, we have the clamps. On the front panel, we have a transparent front panel for the cameras, which are mounted inside. Here you see is the kill switch. The kill switch can be activated any time to completely deactivate the whole system in case of recovery or in case of sudden failure. On the inside, you can see all the electronic systems here. On the top, we have the inertial measurement unit. This is the main heart of the entire UV, as it provides us inertial, the complete coordinates, helps in finding the correct acceleration of the vehicle. This is the laptop where all the codes are run, and the artificial intelligence is there inside the laptop. Its processing completely is done by the processor.
We've left the bot underwater. It's in its autonomous mode, and now, as you can see, we've switched on the code. So now it's running autonomously. It's searching for the ball inside the pool. Once it knows where the ball is, now it's positioning itself in such a manner so as to align itself with the ball. This is how it aligns itself towards the ball, and now finally when it closes into the ball, it's able to nudge the ball, and here it is. This is how the autonomous mode works, and it works successfully this time.
This device not only acts as a research testbed but also as a useful platform for shallow water applications and more.
AUV has many applications in defense, commercial and research. Defense, like underwater mine neutralization, underwater salvaging operations, are very common. Missiles can also be guided. Underwater torpedoes are basically based on the automation principle. These automation principles are being implemented in the VARUN AUV. In commercial application, there are so many underwater resources like oil, minerals and fisheries. Everything can be done.
According to the innovators, this model has been designed with a view to achieve maximum operational standards and reliability with minimum payload and power requirements.